Hello everyone. Do you know how to convert recurring decimals to fractions? Today we are going to learn how to do that, and also I'll explain a short trick for each model without doing the whole process. Right? So let's start with an example. Let us take the first example as 0.2 bar. 0.2 bar. So let us take x is equal to 0.2 bar. Whatever the question is given, let us treat it as x. X is equal to 0.2 bar. Let us write it as in the expanded form. Expansion of this 2 is repeating. Bar is over 2. So 2 repeats. 2, 2, 2 and so on. Some numbers you write. Okay. So here only one digit is repeating. The bar is over only one digit. So if only one digit is repeating, multiply both sides with 10. Multiplying both sides with 10 if only one digit is repeating. If two digits are repeating, you can multiply with both sides 100. So okay, 10 into x gives you 10x multiplied by, and here 10 with you, if you multiply any decimal number by 10, the point moves one digit right side. So the number becomes 2.222 and so on. Right? After multiplying with x 10, bring this x is equal to the original number right under this and subtract 0.222 and subtract now. So I'll get it like 10x minus x, which gives you 9x, which is equal to this side 0.2. So anyhow, point after zeros has no value, we can ignore them. So x is equal to 2 by 9. So x is equal to 2 by 9 is the answer. That means 0.2 bar is equal to 2 by 9. So let me tell you a trick for this. The trick is the short trick. So just if there is a number like this 0.2 bar, so you can write it as, first write the number without decimal as numerator by, and how many digits are repeating. Always the number of digits repeating becomes as, how many digits repeating, write it as 9. That's it. So the trick for this is 0.2 bar is equal to 2 by 9. If suppose there is a number 0.3 bar, so you should write it as 3 by 9. Simple. Right? Okay. Well, let us go to the second example. Let us take the second example. 3.25 bar. Here two digits are repeating. Okay. Let x is equal to, as usual, write 3.25 bar. Expand it. X is equal to 3.2525 and so on. Okay. And here two digits are repeating, 2 and 5. So multiply both sides by 100. So into 100 and this side also into 100. If you multiply any number by 100, the point moves two digits right side. So this side it is 100x and this side it moves two digits right side. So it comes after 325, after point comes 2525 again as usual. Okay. Now bring our original number x under this and subtract. So write 3.2525 and so on. So subtract. Now coming to here, this side 100 minus x gives you 99x, and this side all you'll get zeros after the decimal, and before the decimal 5 minus 3 2, this is 2 and this is 3. So x is equal to, these zeros have no values, so write 322 by 99. That's all. This is your answer. So that means 3.25 bar is equal to 322 by 99. Right? Let us see the trick for this. Directly writing without doing the whole process. So that is, if the number is like 3.25 bar, so without decimal write it as totally as numerator 325, and what number is not repeating before the decimal, what number is not repeating, that you write, subtract from this by the number, how many digits are repeating, two digits are repeating. So for every one digit repeating, write 19. So previously we wrote 19 before, if we have one digit repeating. So if here two digits are repeating, write by 99. So the answer would become like 322 by 99. Right? So this is your answer, which you get here also without a, with working and without working, both same answer. Right? Come to the question number 3. Coming to the third example, 2.47 bar. Here the bar is only for 7, not for 4. Okay, but point after you have two digits, but bar is only for 7. So such type of examples. So let us take x is equal to, as usual, 2.47 bar. Let us expand this. X is equal to 2.4777 repeats. Right? Next. Here also, again, only one digit is repeating. So, multiply both sides by 10. This side multiply by 10, this side also multiply by 10. If you multiply any number by 10, the point moves as usual, one digit right side. So, this side 10 into x gives you 10x. And this side 24 after point comes and write 777 as usual. And bring our original number x here and write under this and subtract 2.477 and so on. Right, and subtract now. So 10 minus x, 10x minus x, 9x, which is equal to this side 0 0. Here point after you have a digit here, 7 minus 4 3, and 4 minus 2 is 2, and right here 2. So these two zeros have no values. So x is equal to now 22.3 by 9. Okay, 22.3 by 9. So to remove this point, what can I do? I can multiply both sides by 10 up and down. So if I multiply both sides with 10, I'll get in the numerator 223. The point moves one digit right side. So 223. The point goes away from the number, and denominator 9 into 10 as usual, 90. Okay, so the answer x is equal to 223 by 90. So the original value of the 2.47 bar is equal to 223 by 90. Now let us see the trick. Without doing this whole work, you can also do the working. I mean, you can write the trick like direct answer when it comes in the competitive exams. You can no need to do the whole working. So the question is 2.47 bar, right? So here you write first of all the total number without decimal and without bar as the numerator, 247, and here the number which is not repeating along with the decimal number, before the decimal or after the decimal, whatever the number, total number is not having decimal, you write, I mean, which is not having a bar, you subtract from this 24 by, and now check here how many digits are having a bar. Only one digit, so 19 for that. And how many digits after the decimal we have no bar, that takes as 0, that represents as 0, represent it as 0. So the number which is having bar, represent it as 9. How many digits are having bar, represent it as 9. How many digits after the decimal, don't count 2. After the decimal, whatever digit is there without a bar, that you take as 0. So the number is 90 in the denominator. So now subtract numerator 247 minus 24, it comes to 223 by 90. So which is same as our answer, what we did with working also, same. So you can use this trick here. Okay, so we'll go to one more example. Let us take the fourth example, like 5.614 bar. Here also the bar is only for one digit, but before the point, before the bar, you have two more digits after the decimal. They don't have any bar. So 6.1 has no bar, but 4 is only having bar. Let us think x is equal to 5.614 bar and expand that according to number of decimals repeating, right? 4 4 4 4 and so on. So here also only one digit is repeating. So let us multiply both sides with 10 into 10 into 10. That gives you 10x is equal to, the point moves one digit right side, so 56.144 and so on. Now bring our original number under to this and subtract 5.614 and so on, 444 both sides. So down, subtract them. 10x minus x gives you 9x, which is equal to this side 0 0, 4 minus 1 3, this is 11, 11 minus 6 5, and this becomes 5, 5 minus 5 0, and this is 5. So 50.53, and these zeros have no value. So x is equal to 50.53 by 9. Right? So to remove this decimal, I'll multiply both sides because two digits are repeating here. Multiply by 100 to get away the decimal, and here also multiply with 100. So I can get the answer as, now the numerator becomes 5053. The point moves away from the number as we multiplying with 100. By denominator 9 into 100 gives you 900. So this is the answer of x value. That means 5.614 bar is equal to 5053 by 900. Now let us see the trick for this. Okay. Let us take. The trick is, let us take the question 5.614 bar, right? So let us take the number as it is as a numerator, like 5614. First write the number, whole number without decimal and without the bar. Minus, I told you, you have to subtract the whole number without a bar, whatever the digits are there. Subtract 561. Denominator is how many digits are repeating, that take it as nines, and how many digits after the decimal we have not having bar, treat them as zeros, take zeros for that. So the number comes to, subtract the numerator, 5614 minus 561 becomes 5053. Denominator 900. That's it. So which is the same answer as ours, right? We'll see one more last example. Let us take the fifth example. 4.562 and the bar is for 62. Last two digits bar is there, and there is a digit without a bar after the decimal. Okay, let us take this. Let x is equal to 4.562. 62 is repeating now, 62, 62 if you expand, and so on. Now as here two digits are repeating, right? 6 and 2, two digits are repeating. Multiply both sides with 100. So this side also multiply with 100. So the point moves two digits right side, right? We'll check it. 100 into x, 100x is equal to, the point comes to after 6. So 456 before decimal. After the decimal you have 2 left here. 2, 6, 2, 6, 2 and so on. Right? Bring our original number down to this and subtract. So we have 4 point right under 6, 4 point. Point should be in the same line, right? You know, 5, 6, 2, 6, 2 and so on. Subtract. We'll get it here, 100x minus x, 99x, which is equal to this side. If you subtract, where you have same digits, you can put zeros for them up to here. Okay, 12 minus 5, which is 7. Point, this 6 becomes 5, 5 minus 4, 1, and this is 5 as it is, 5, 4. So x is equal to, you write, these zeros have no value, 451.7 by 99. So as we have one digit after decimal, so let us multiply both sides by 10 to make it free from the decimal. So we can write it as 4517. The point moves after one digit, so the number becomes 4517 numerator by denominator 99 times 10, 990. So this is your x value. That means 4.562 bar is equal to 4517 by 990. Right? So let us see the trick. So trick is directly writing the answer without doing the whole process, which is 4.562 bar is our question, right? So first of all, write the whole number without decimal and without the bars, 4562 minus the numbers which are not having any bar totally, before the decimal, after the decimal together, 445. Denominator, now observe carefully, you have two digits with a bar, so 2 nines for that, and one digit with without a bar, so after the decimal, don't count 4, for that 1 0. So 990 becomes the denominator. So 4562 minus 45 gives you 4517 by 990. So which is same as our answer, right? So like this you can do with the trick without using the total process. So this will be useful for competitive exams to write the direct answers. Okay, right. Thank you.